All right. Wonderful day. Kat, how are you doing today?
Hi, hello, Deshaun. Hello, guys. I'm fine. I'm great. Super excited about our talk today.
I'm still kind of buzzing. I enjoyed our talk last time. Look at Harpreet is here. Wonderful to see you, Harpreet. Thank you so much for joining. And Buildpacks is the thing. Buildpacks is a great tool. It's a time saver. It's a safe way to go to production. And I talk about it a lot.
Yeah,
And I'm happy that you're back. So let's jump in. Uh, why?
yeah, yeah.
Why? Why should we use Buildpacks?
Right. So build packs are traditionally opposed to Docker files, right? And there was an opinion that even if you use build packs, you can be more flexible with Docker files. So build packs give us this great acceleration boost in our developer productivity because we don't have to write Docker files. You can use build packs just with one line of code and you have a ready container image. And that is great, right? But before that, I've heard opinions that, well, if you use build packs, then you get kind of a black box or a cat in a sack, right? So you don't know what's there and you don't know how to control it. And uh, today, I am going to show you to demonstrate how easy it is actually to configure build packs to your project's needs and still have this super great acceleration in the build time in that you still have to use one line of code to build a container image and just maybe a couple of lines of code in the configuration file to add the necessary configs, and that's it. So build packs can be just as flexible as Docker files, and still they give you this great acceleration. Plus, you always stay on the latest version of the JDK and Linux if you build packs, so you don't have to update anything. In Docker files, you have to always keep track of the versions, right? And you have to maintain Docker files, and this can be troublesome sometimes. Well, with Buildpacks, you don't have this issue, right? So every time you rebuild your container, you get the fresh JDK version and Linux version. That's great, I think.
I think it is. You said configure. That's one of the things that a lot of people forget. They don't realize. So I think today we're going to talk about the ways that you can configure build packs, right? With I said it last time with JVMs. I say it's one size fits most, not one size fits all. And you, I think, as a developer, architect, I think you have a responsibility, maybe even SRE, like a responsibility to try different configurations, different settings, different garbage collectors, for example. So,
Yes,
so
exactly.
let's dig in.
Yeah, let's dig in. All right, so I'm presenting my screen. Okay. Share screen. Okay, just a sec.
While you're doing that, I'll invite everybody. If you're here joining us, say where you're joining from. Say hi and let us know where you're joining from, because my mom and dad, they always watch and they like to see where everybody is joining from. So yeah, say hi. Tell us
All
where you're
right.
from.
Okay.
Could you
Okay.
bump up
So
the font
yeah.
one time?
Mm-hmm.
Could you bump it up? Bump up the font.
Sorry, just a sec. Um. So
Uh,
like that.
uh, can you make the font bigger?
The font bigger.
Yeah,
How do
Command
you font?
plus, I think.
Uh, oh yeah,
There we
that's
go.
great. That's
There
great.
we go. Yeah.
Uh,
Now you
yeah,
can just scroll down. I think it'll be there.
just a sec. Yeah.
So we have our
Uh,
first question here.
all right.
And Rajiv says, please give us an example where a single project has multi-modules and individual build Gradle files and how to configure these build packs, since usually production service apps has this kind of setup. Um,
Right.
but Rajiv, I think we'll come back. Individual build Gradle files is fine in multimodal or multi-module uh, apps. That's fine as well. So I think that you're asking for, like, you want one container that's wrapping up multiple modules. Is that what I'm hearing? Like, fill us in the cat. Again, this is interactive. When you come to my house for dinner, if you leave hungry, that's your fault. So you're here joining us in the live stream. Get your questions asked. But it's these kinds of questions, right? I get it. If you've got unique build process, uh, I understand that, hey, I don't want to use something else, but I'm pretty sure, and maybe I'll do that on the side. I'm pretty sure that the build packs will allow me to do multi-module uh, application already. So yeah, um, thanks. Great question.
Yeah, it's a great question. But yeah, today, so I wanted to show you our favorite pet clinic. I promise this is the last time I use the pet clinic.
Oh no, Pet Clinic is great. It's a
Yeah,
great application that shows a bunch of things. It has these patterns, things that people are going to see out in the world. So yeah, continue to use Spring Pet
yeah.
Clinic. It's a great project.
Yeah, well, but anyway, here we are using Buildpacks, we're building container images. So right now we are, we're not doing anything with the insides of the application, right? So the only thing that we are going to twist is the configuration file. That's it, right? So, and let's dig in. So first of all, let's look at the palm.xml. Right. So here we have, if you can see that, I guess you can, right? So our Spring Boot Maven plugin, right? And right now, the only thing I added is the name of our future image, Pet Clinic Standard. So I haven't changed anything in the configuration, and we are going to start with building a container image with the build packs as is, with all the default settings. So just as I promised, one line of code. Right, and then we will see how we can work with this image, right? How we can tune it to our liking, right? So the memory footprint, the startup time, and so on and so forth. Right. Okay.
So this is going to be using, well, actually, it depends on how you build it. All
Yeah.
right, so you're using MVNW Spring Boot build image.
Yeah. So we are using Maven as our partner, right? So but there's a Gradle also available, so you can grab it too. But this time it's Maven. All right. So we are building the image. And while it is being built, let's look at the terminal, the outputs, and yeah. So if you want to start configuring build packs, you can look, of course, in the documentation. But even here, you can see the different options that you can use, right, and that you can configure. So there is a jlink that we're going to look into today. You can choose the JVM version, debugging configuration, GFR. You can enable GFR.
What's
Yeah,
JFR? Oh,
GFR,
flight recorder.
Java Flight Recorder. Yeah,
Okay. Yep.
so for profiling. Yeah, and well, lots of other things. So
I never thought about how that kind of like self documents the build packs and the options that you have. So that's great. But
yeah,
we did this, and by default, the Spring Boot Maven plugin is using a Paketo build pack.
yeah,
Right.
exactly.
So it's using the Paketo
Mm-hmm.
builder
And
Tiny,
yeah,
I think.
yeah. So it's Jammy, Ubuntu
Yep.
Jammy for Linux, and for JDK, it's using Liberica JDK. So the version here is 21, but you can choose other versions if you want to, right? But we are going with the latest LTS release. And here are the configurations that Spring Boot enables us to use. So CDS, AOT, we are going to look into that today as well.
One
Right?
thing that I got caught up on recently, you said it's going to use the LTS version. I think it uses the LTS version by default.
Mm-hmm.
I like to stay on the later versions. So I had been using Java 22. I've been configuring my build packs to use Java 22. And recently, September 17th, Java 23 was released. And shortly after that, the build packs, they removed Java 22 from the build pack in support of Java 23. So they're going to keep the LTS versions. This is the Paketo's approach. They're going to keep the LTS versions. But when a new non-LTS release comes out, like Java 23, the other non-release or non-LTS releases, those disappear. So if I wanted to stay on the latest JVM, I had to go and upgrade to Java 23 from Java 22. And that's okay.
Yeah.
I like that little push. That helped me. I was just throwing that out there. I got caught by that.
Exactly. Well, that's the same model that is used with any JDK release. So LTS versions receive CPU and PCU updates for about 7 years. Well, that depends on the vendor. Belsoft provides updates for 7.5 years for LTS versions. And the latest feature version is updated until the next one comes out, and then the next one is updated. So you are kind of on a roll. If you want to use the latest and greatest, you update to the latest version, right? And if you want to stay on, well, if you need stability in your production for several years, and that's okay too, right? Well, you should stay on LTS version. In this case, right now it's 21, right? And yeah, so that depends again on the project purposes. Okay, so another thing I wanted to show you is that Spring Buildpacks create layers of our application. And the last time, if you watched our live stream about Spring Boot Startup, when we used Docker files, we manually created exploded jars and copied the layers of the application into the new Docker file, into the new image. And here, we don't need to do that. Spring Boot does that. Spring Boot Buildpacks do that for us.
Yes, so, this is another thing that I've been talking about, is that these little tips and tricks that we don't often see. I even spent some time this week going and looking at blog posts on how to build Docker files for Spring Boot, and very few actually exploded the jar in the Docker file and started up as an exploded jar. And we've had that like from the beginning with Buildpacks. So yeah, these are little things that, yeah, you got your app running in the Docker file, but it's not running its best. It's not optimized.
Yeah, exactly. And with layers, and again, I love that too, because you don't have to do anything. Buildpacks do that for you. They create layers and then they create the layered image. And that's just great, right? So that simplifies life of the developer greatly, I think. Okay, so our image is ready. Let's check it. So with Docker images, pet clinic. Okay, clinic. Okay, so here it is, pet clinic standard that we created, and it takes about 390 megabytes. If we dig into the image, so Docker history, clinic standard, we will see here our layers, right? So the top layers are super small. And then there are these application layers with dependencies, with the launcher, with the application as it is, the software bill of materials, right? And here you can see the JRE, and it takes about 207 megabytes. Okay. Well, that's okay, but we can do better.
Okay.
Right. So what we need to do is to actually get rid of all the JDK modules that our application doesn't need. And that's what we can do with jlink. Okay.
Interesting.
Yeah. So let's go to our home.xml. Okay. Okay. Right. So first of all, let's change the name. It's going to be Pet Clinic jlink. And we have to add the environmental variable. Right, so this is the terminal. So the layout is not going to be pretty.
It's okay.
That's okay. That's totally okay. That's not actually, that doesn't mean anything. Okay, so we want to use jlink. So for that, we need the variable called bp jvm jlink enabled. Right. And we're setting it to true. So, and here the same, jlink.
So what is jlink?
So jlink is a very useful and I think very underrated tool that enables us to cut out a custom JRE for our application. So we don't have to pack the whole JRE, well, especially not JDK, but that's not the case with Liberica. So yeah, just a little bit prehistory. So well, before that, we used to, well, really long before that, we could pack our application with the whole JDK, which is, well, not necessary because it's going to take a lot more, right?
Mhm.
Then there is an option to use only JRE, so that contains module requires for the application to run. And that's already, well, better. But we can go even further, and we can cut modules out of this JRE, only those that we need. And depending on the application, well, the difference can be, well, quite significant, quite tangible.
Okay.
Right. So that's it. Nothing else, right? So nothing else to configure.
So this enabled.
This enabled. Let's
The
build.
JRE is going to say, hey, don't package the modules that I'm not using.
Yeah, exactly. And we're going to use, and we're going to see the difference in the size. And this option, well, it's pretty good because it adds the modules that your application requires. And there are ways to configure jlink as well. And that's what we're going to see a little bit later, just right after we build this image. But you can use JDEPs and see which models your application uses and add only this, specify all these modules as a list for jlink to use. But with Buildpacks, it's not actually necessary because Buildpacks do a very good job at determining which models your application requires. And so you don't have to list all those modules. Buildpacks do that for you, which is just great. Okay, so our image is ready. And as you can see with jlink, it's already 281 megabytes. Well, was 100 megabytes off.
Yeah.
I think that's a great result.
That is.
That's great. Yeah. We can go even further, right? So we can add these jlink arguments that I've been talking about. Let me show which. So, okay. So first of all, we can add compression. So we can compress the modules of JRE.
Okay.
And that will enable us to save disk space.
Okay.
Then we can remove header files and manual pages because we don't need them for the application to run, and then save some megabytes as well. And I'm going to show you one almost secret option because nobody uses that. But
I like those. I like cheat codes.
Really, that's awesome. This is, well, as you may know, the Hotspot JVM packs 3 VMs. So there is server VM, client VM, and minimal VM. So minimal VM is fit for embedded systems. Server VM gives us this excellent Java performance that we love. Client VM, well, the performance of client VM is similar to that of native image, which is quite okay, quite optimal. And for some projects, that's enough. But what client VM does is that it enables your application to consume less CPU and less memory and start up a little bit faster. So just with client VM, if your application is fit for that, of course, you run the testing, the load testing, the stress testing, and see how it works with your app. But if it's okay, then you can save even more memory, and and that's going to be totally fine.
I like what you're saying. So here we've already shown how we can reduce the size of the image, and that's great. And you might be asked, like, well, disk is cheap. Like, what does that matter? It matters when you're sending it across the globe to, a dozen data centers, and you're spinning up, 20 instances, et cetera. That disk size, that container size matters. Embedded systems, we're going to have more and more workloads running in places that are outside the data center as well, and those image sizes matter. There's a good question. Hey, good morning, Thomas. There's a good question here. Will there be any runtime improvements between the JLink image and the standard image once loaded? I think because we have less, I think it's going to have a little bit, I would expect maybe a little bit faster startup time, but I'll let you
Yeah, we are going to run our images, of course, and we are going to see how much memory our containers consume. So that's all going to be there. Right now, we're just building stuff, and then we're going to test it all, and that's going to be great. Yeah. So we will see that just live. We will see that as it is. Okay, so to enable jlink arguments, and there are lots of them actually. I'm going to show you some of them, some of the most useful ones. But you can run jlink help in the command line, and then you see the great list of options that you can use, like sleep debug, for example. You can do that. It's not really what is recommended, but you can do that actually. Right. So for some purposes, maybe it's okay. And then you can add modules, as I already said, so you can just list them. But again, Buildpacks do a good job for us, so we don't have to do that. Okay. So let's add compression. Compress. So zip 6. Before that, sorry, typo. Right. So before there were different levels of compression, 0, 1, and 2. So 0 means no compression, 2 highest compression. But these options are now deprecated, and instead of that, we use zip.
Okay.
And zip 6 is about similar to compress 2.
Okay.
Right, then we are removing header files. No header files. No man pages. And we are using this client VM. VM client. Okay. And we're going to call our image pet cleaning jlink advanced.
Nice.
Right. So, yeah. Okay. Let's build it. Right. So yeah, as you can see, it uses Jammy, Ubuntu Jammy, and I'll show you what we can do about that as well. Right. So in Buildpacks, you can't actually, in standard Buildpacks, you can't choose another Linux base image. You can choose another JDK, not Linux. But in a few minutes, I'm going to show you how to what we can do about that too.
And we can also build, like Buildpacks, there's a specification out there. So we can also build our own. One of these other questions, I don't know off the top of my head if there's a way to add configs. For me, I know that I can, hey, like my internal certs, I want to have a build pack. I can create a build pack that says, hey, go grab these files, go grab this agent, go grab this thing and put it into my build pack. There's tons of examples of that, adding things. Build packs can be stacked. So you don't just have to use one build pack. If you've got a build pack that's building Java, you can also grab another one. Can you scroll up? And in this build pack that we're using, Cat, if you scroll up a little bit, it does two things. The build packs have two phases. They have a detect phase and a build phase. So at the beginning, it's going to say like we're using 26, I think, different build packs. Keep going.
Yeah.
There we go. It says 6 of 26 build packs participating. And each build pack is going to do its detect phase. Like, oh, do I see a file? Do I see a configuration for me to do some work? If I don't, move on. So there's 6 of those build packs that were in this build pack collection said, oh, I'm going to participate. One saw that it was a Maven project. One saw that it was Spring Boot. One saw that it was Java. And then for adding the bill of materials and certificates. So they all said, hey, yeah, I'm going to participate. So if you add something specific to what you're doing, you can add a build pack. And the benefit of adding a build pack to do that is the consistency across your org. Because if adding a file to your builds, to your containers, is the only thing that's causing your dozens or thousands of developers to write Docker files, that's not the best, right? If your developers are in charge of writing Docker files and the applications that they're taking to production, that's just more work. When we could write a build pack that will do the thing that you need and make it consistent across the org. because even in your example, you're like, oh, hey, we do it this way. Do run ad, and we put it into a secret place, or we put it someplace. But a lot of things have to be configured properly in order to go down that route. So yeah, we can make changes here. This is great.
Yeah. So you can add certificates, or you can disable certificate helper. Right. So and that's it. Yeah. So that's quite flexible actually, the process. Right. And so meanwhile our image is ready, and you can see it
Even
takes
smaller.
42 megabytes, even smaller because of
Now,
compression, because we use
I'm smiling like I'm watching a good movie because I'm waiting for the ending. I'm waiting to see how small are we going to get these container images. How fast are they
yeah.
gonna serve? So I'm eating my popcorn. I'm ready to go. This is great because I'm getting the sense that I can do these things with jlink, and then I can also do some of the other things that we've talked about in the past.
Yes. So so right now let's sum up what we did. We used jlink, so we added only modules required for our application to run. Then we used compression for the modules, right? And we enabled client VM, so we didn't add server or minimal VM. We added only client VM, which is smaller. What can we do now? Well, as I already mentioned, you can't actually change the Linux-based image in the official Paqueta Buildpacks, but you can use another builder with another Linux distribution. Yeah. And guess what? We are going to use the Alpaquita Buildpacks.
All right.
Yeah.
And this is going to be easy, right?
Yeah. Super
the
easy.
Buildpack specification
One line
allows
of code.
us.
That's
Fantastic.
it.
Let's go.
Yeah. Okay, so for those of you who don't know, Alpaquita Buildpacks are based on Liberica JDK Lite, which is a special version of Liberica JDK. It has better model compression ratio and some enhancements backported from the newest JDK versions. So the team backports them to the previous JDK versions, and so Liberica JDK Lite is the same Liberica that you love, but it's just smaller.
What are the trade-offs? What do we trade off in order to get the smaller size?
Yeah, so there are trade-offs. Yeah, thanks, Dashawn. Actually, yes. So you get smaller disk size, but the net size grows. So the deployment time is a little bit bigger, right? So because we use compression, and now we need to decompress, right?
Okay.
But this difference is actually almost negligible because we don't use the highest compression ratio.
Okay.
So the highest one, as I showed you, we are using zip 6, which is about the second one, similar to compression 2. But the highest compression ratio is zip 9, and we're not using that because we don't need that this time. Right. So okay. What we need again, and yeah, so the Buildpacks use Liberica JDK Lite and Alpaquita Linux, which is really, really small. Okay, so where it is? So we are going to give another name: Pet Cleaning jlink Advanced Alpaquita. And what we need is to add another builder. So to specify it, and then that's it. When we trigger the build, this builder is going to be detected and used as the base image. All right, so Bellsoft, Buildpacks, builder, muscle. So Alpaquita Linux is based on muscle libc, but glibc version is also available if you need that.
Okay.
But we're going to keep to muscle. And yeah, so jlink is there, jlink arguments are there, so we specified the builder, and that's it. Okay. Let's see. Okay. So yeah, this time the Alpaquita Buildpacks are going to be used. The configuration options are mostly the same. The only thing is that Alpaquita Buildpacks don't support CDS right now. But, maybe because there was not much demand for that feature. So yeah.
I think from, if I'm recalling correctly, I think the muscle images will be smaller than glibc.
Yeah, exactly. Yeah. So the muscle version of Alpine and Alpaquita is about 3 MB or 4, and the glibc version of Alpaquita is about 7 or 8. So kind of
Okay.
like that, which is also actually smaller than standard Linux distro space on glibc.
Yep, and
Okay.
I'm
Yeah.
pretty sure I think I'm aware that there are teams of developers out there that when they build native images, they build them with muscle instead of glibc because there's an additional benefit for using muscle in some cases. Right? There's always a trade-off. So one of these questions here is like, hey, we've got 3 already, but like, what am I losing when I get these smaller images? And in some cases, not a lot. Right. In some cases, it's going to be startup time. In some cases, it's going to be memory footprint. But performance, it's still the JVM. We've optimized to get rid of things that we don't need. And if those needs change at runtime, right, then maybe these aren't the best. If you've got class paths that are changing after you've built, then yeah, maybe that's not the best route. But the changes that we've seen so far are pretty easy. We're making one config change. And I'm going to say, I'm okay with building multiple images as a part of my path to production because sometimes some places I want to deploy one that has muscle and maybe I want glibc on other platforms. Maybe it doesn't support muscle, but building multiple images that are sitting in my container registry, that's okay because maybe for development it's good. Maybe for stage it's good. But you've got to do the work. We can't answer all the questions and say this is the right combination to use because every workload is different. You've got to do this. But what you're showing us here is it's not hard at all to make these simple changes to tweak different numbers. We have options. This is great.
Exactly. Yeah. So Lashon is right. There is no one size fit all solution, but there are multiple solutions. That's great. You can test and test and test and see which one is good for your project, right, and for your needs. So that's quite okay. Testing is okay, right? So we're just looking for what's good for us. Okay. So our image is ready, and as you can see, the Alpaquita-based image takes only 133 megabytes. Remember that we started with 390.
Yeah.
And here it's almost 3 times smaller.
Now, we changed the base operating system, right? A lot of people will use like a Alpine or even one of the, what do they call it? Distroless, where, hey, it's like the kernel and you're adding things to it. But we're getting a lot of benefit here. And this matters, right? Again, this disk size matters going over the wire. But then we also changed to muscle, like instead of having glibc on there. So we've made some pretty significant changes, but all of the changes between this build and the last build were on the things that are below the application layer.
Exactly.
So fantastic.
The beauty of it is that you don't have to touch your application. You don't have to change anything in your application, right? So whatever that we're doing something beyond the app itself, right? So we are just looking for a perfect wrapping for it, so to say. So we switched to muscle, and that's important, right? Muscle is more performant in some situations than glibc. In other situations, its performance might be inferior to that of glibc, but the Balsaf team actually optimized muscle for Alpaquita, and the tests show that the muscle-based Alpaquita has performance equal to that of glibc-based Linux system.
Okay.
So we are actually removing those obstacles that prevent people from using muscle.
Fantastic.
Which is great, yeah. And Alpaquita Linux is the only Linux optimized for Java. So it means that, first of all, it has 4 mallocs for different Java workloads, right? Again, so you can use different mallocs and see which one is better for your workload. and its repository always contains the latest versions of JDK, Liberica JDK, which is also important, right?
Okay.
So yeah, it's Alpaquita, I dare say, is a perfect Linux distro for running Spring Boot apps.
Okay.
Okay, so here what we have now, 4 images, right? So we went from, again, 390 megabytes, right? We removed the unnecessary module from our JDK. We compressed the image, and we used another base OS image, and the resulting size is, well, the difference is striking. So 3 times.
I don't know how good my math is, but that's like less than half the size.
So 390, 130, it's 3 times, right?
Right. That's
Yeah.
crazy.
Yeah.
Crazy.
Right. That's great. That's I love it. And again, we didn't change anything. Well, we didn't change much, right? So we added just
Right.
a couple of lines of in our configuration file. Right. So the moment will come when we run all those images. But right now, let's return to our, or maybe we can run this
Yeah,
guy,
that's great.
and
Let's
then
run
move
them.
on to IoT and CDS. Okay. So right. So what do we want to see? We want to see startup, and we want to see the memory consumption, right?
Sure. That sounds
Okay.
great.
Okay, so let's first check the startup if it's any difference. I'm removing the container. We will well, change the settings, but for now, let's just check the startup. So Docker run, and let's set the memory limit to our application. And yeah, let's start with the standard one, pet cleaning standard. Okay, that's it. Oops. I guess. Oh, Docker run. Yeah, sure. Silly me. I didn't actually run anything. Okay. Yeah. Another interesting thing that I wanted to show you is that when you run your containerized image, the Buildpacks will configure the necessary JVM options, such as heap size,
Yep.
code cache size, right? And the calculations are based on a very, very difficult formula used somewhere under the hood of Buildpacks. And as we will see later, these calculations are pretty good, pretty close to what we will see in reality, how much memory our application actually consumes. Right.
Yep. The memory calculator is another massive benefit of Buildpacks.
Yeah.
It's squeezing out, right? When you're sending these containers to production, size matters, right? The reservation matters. So these are things, again, that if you're trying to optimize your Docker files, this is a lot of extra work that you're doing when you get these benefits for free with Buildpacks. So this is fantastic.
Yeah, that's great. So look, our application started in 4.3 seconds. Okay, that was standard one. And after you exit the application, you will get the native memory tracking logs, right? And you will see how much.
How did you do this? What?
I didn't do anything. Buildpacks did everything, right? So we didn't change anything. We the native memory tracking was enabled with Buildpacks by default.
That's great.
You don't have to change it. That's just amazing. I love Buildpacks for that, right? So all is here at your fingertips.
Yeah. I love it. So looking at this, do I see like maybe the peak number? Here's
Right.
the reserved.
Yeah, so total, reserved, and committed. As far as I know, it's
perfect. That's great.
Yeah. So right, this is how much memory our application actually needed and consumed, and that's how much was reserved.
All right. So the committed value is the one that's going to change. That's the one that we're going to look. Okay. Fantastic. Yeah. Okay. So we're looking at 229 megabytes.
Right.
Ish.
So
yeah, let's say 229 megabytes.
Yeah.
All right, this is great.
Okay, so let's run our next image. That was jlink, right? So pet cleaning jlink. Okay. Right. So here the startup is almost the same.
Yeah.
Yeah. So, but jlink doesn't actually affect the startup time that much, right? So
Yeah.
I don't think we're going to see any striking difference, but
Yeah.
anyway.
That's an example. Still, right? To have a similar start time. We made a change and similar start time. So start time we'll just say not affected. And let's look at that committed number.
Oh, yeah.
And that committed number here is
Um,
similar.
that's similar. Yeah,
Similar.
similar.
Okay.
Okay. But again,
Simple
we are.
change. So our big benefit here is the container size. So we use
Mhm,
JLink, nothing else. We got a smaller container. Everything else pretty much
mhm.
stayed the same. Does everybody agree? Like, hey, chat, does that look right? That makes sense. Because all we did with JLink, we just said, hey, throw away the modules I'm not using. So the expected, benefits of that is just a smaller container size. Everything else should be the same. I can
Mhm.
get down with that.
Right. Yeah. So the JLink Advanced, so that's with the JLink arguments and with client
Okay.
VM, started in again 4.3, which is
Yeah.
okay.
Similar.
That's totally fine, similar. And the last one is Alpaquita,
What
right?
was the memory on the
Yeah, yeah, yeah,
JLink
yeah.
Advanced?
Right. But yeah, we are going to run all these
A little
images
bit smaller.
and
So
check the
here we're at
yeah.
205. So we did see a
Mm-hmm.
little bit smaller at this point in the application. Like this, okay, this is great.
Yeah, yeah. All right. Okay, so and that's the JLink with Alpaquita. Again, the startup is the same,
Similar
but
startup.
yeah, right now we are going to, so here it is the committed. Yeah, so similar to the previous one. Right now we are going to run all these container images in detached mode, and we'll see in real time how much CPU
Oh,
our
perfect.
containers
Okay.
consume. Yeah. So that's okay. So Docker run. Run, we don't need a run. We need D. Let's limit our application to 1 gigabyte, and let's give them some meaningful names. So there's going to be pet cleaning standard. Let's call it pet std.
Okay.
And yeah, so that's pet cleaning standard. Okay, the next
It's like
one.
timing matters, right? So
Mhm.
when I do a similar demo where I'm kind of going through these different options, you can type, but that timing matters. Like when I take my samples of the JVM, that matters because the JVM is always optimizing. So I try to make it so that my samples are
Mhm.
consistent.
Yeah.
Like
Yeah.
I take it 2
Mhm.
seconds after startup because if I wait 30 seconds, maybe some optimization happen. But also it depends on load. I think I saw, uh, yeah, there's differences that's going to optimize over time, but the timing matters. So this way, we're going to have all the apps up and running, and we're going to kind of see how they're behaving
Yeah. And so
with
here it
neighbors. So not just on their own; they're going to be with neighbors.
is.
So now we have CPU,
Yeah. Memory
which
usage. Yeah.
the
Mm-hmm.
CPU is clearly lower on the top two, on the JLink Advanced and the JLink Advanced Alpaquita.
Alpaquita. Mm-hmm.
So
Right.
that's interesting. Oh, they're moving around. All right, the
Mm-hmm.
memory usage
So yeah,
looking
there
good.
are spikes and yeah, memory usage. Yeah, again, you can see that JLink Advanced, that's with client VM, and
Yeah.
Advanced with Alpaquita, they use less memory, right?
Yes.
So yeah, we can see that clearly, right? So about 100 megabytes less, which is great. I think that's great. Yeah, that's important. Yeah, for many applications. I don't think that it's going to be true for all applications,
Uh huh.
right? Again, for maybe smaller ones,
Okay.
we can get this great result.
This is
Again,
still
testing.
fantastic.
Still, yeah, you can see that's very well. That's a good demonstration, right?
Yeah,
So
love it.
yeah.
So these are all things that any developer can go out and try. We didn't do a whole lot of coding. We changed some configs and we got great results. All right.
Yeah.
Let's keep going. This is great.
Yeah. Mm-hmm. I love it. Okay, so home.xml. Okay, let's move on. So the next thing I wanted to show you. Okay, let's remove the builder. Okay, we are going to go back to our standard builder. Okay. So we had jlink with arguments, but you can add other options. So you can, for instance, if you want to add some JVM options, runtime options like heap size or garbage
I can
collection.
override. So we showed that we had that memory calculator, but again, the memory calculator is going to do a great job for 99% of the workloads that are out there, 99.9, I'm going to say. But sometimes, yeah, optimizing for that extra millisecond is going to be valuable. So we can override those things. There's still the flexibility exists all the way down.
Yeah, exactly. So to do that, you need BP, JVM, no, Java tool options, Java tool options, and here you can change anything you want, pretty much, right? So for instance, we want to use ZGC. I imagine you want extra small pauses, and or you have a great heap of several terabytes, then you can use ZGC collector. So with the standard options, nothing fancy. So everything that we used to, right? XX and use ZGC. And that's it. Okay, yeah. We are not going to build an image with ZGC or with another collector because we can't test the performance right now.
Okay.
The results, and that's irrelevant to Buildpacks, right?
Okay.
So that's
but we can do it. It's the option, right? Maybe we'll do that on the next show.
Exactly. Yeah, why not? But anyway, here with Java tool options, you can. Sorry, that was a typo again. My mistake. Right, Java tool options, right?
Okay.
You can, so change the heap size, so any parameters, so we'll choose another collector, tune the collector, whatever, right? So here, that's where you can change it all. You can change the JVM version, right? So for instance, you want to use the latest and greatest, and here, that is VP JVM version. Yeah, and here, you can 17 or 22. Anyway, any version, right? Even 8 if you want. Right, it's there. Well,
kids. There might be kids watching. Don't do that.
Right, but still, that's an option.
Family-friendly show.
Right, it's something that you will do in the dark after midnight. You're
Education
going to
only. Yes. Yeah.
Yeah. So during the live stream, it's 21, the latest.
21 or better. Yes.
22, better. But then again, after the live stream, it's okay. Where's my
experiment
Java 8?
only? Yeah, be safe. Right?
Yeah, exactly. All right. So what we did up to now is we looked into memory consumption and how we can reduce that.
There's a question here from Rajiv. Rajiv, I thank you so much for all of these good questions. This helps us, and I think it's helping everybody. You have to get your questions asked. And he asks, will there be any overhead of having native memory tracking in Buildpacks in runtime? And I don't know how to answer that. I'm thinking that the sampling that it's doing, right? And I think of the agents, the JVM agents that we used to attach to give us all of that information. And depending on what the agent was doing, when we were attaching agents, depending on what the agent was doing, there was some overhead. But here, by just enabling it, we're not adding any work. We're exposing metrics that I think my platform needs in order to keep it healthy. But could I disable the memory image tracking, and what would that benefit be, and how would I know? So that's a good question. And Rajiv, I think I want to take that one offline because I don't know the answer. Kat, do you have an answer here?
As far as I know, yes, you can disable the native memory tracking.
Yeah.
I can't tell straight away how, but you can. There's an option.
Well, fantastic.
So,
So we'll do an experiment. We'll add that to the next one. We'll look at the garbage collectors, and let's talk about, like, hey, how's it behaving memory wise? I think this is a great next show. So Rajiv, thank you, and I'm going to expect you to be on the next show as well.
Yeah, it's going to be fantastic. Garbage collection is a great topic.
Yeah.
Yeah, so that's
I say just
and
like JVMs. Once
deserves
you
its
figured out your JVM, like there's another kind of option there. You're using Bellsoft, but you don't have to use the same garbage collector for all of your workloads. Different workloads have different behaviors, characteristics,
yes,
and you can optimize those for the
exactly,
workloads. It's another
exactly.
knob that you need to turn or check.
So there are seven garbage collectors. You can choose any one of them,
Mhm.
right? There's even this my favorite Epsilon GC that doesn't do any garbage collection.
Okay.
Right, I love it. But actually, it has its purpose, right? So there are applications that almost don't produce any garbage, or short-living applications, right? That
Okay.
don't have time to produce garbage. Then the Epsilon GC might be good for them.
Oh,
And then, yeah, you're not getting any garbage collection overhead, memory overhead.
you're
So yeah,
blowing my mind, Kat. Like you're at a different level of like where your focus is. And there are things that I'm learning here, even just like reminders about like Docker history, but you're bringing up some really, really valid knobs, some valid things for me to check. And this idea,
yeah,
we talk about short-lived uh, scaling workloads. One of the reasons why we use containers, and a container that's not going to stick around for a long time. They might be in a chain of functions, right? It's a reactive functions, calling functions, calling
yeah.
functions. Instead of writing down to disk, they're just calling another function. We talked about this on Spring Office Hours yesterday with Cornel, and this idea that there are things that we can do if we're really trying to squeeze out these milliseconds. Uh, that's amazing. I never considered the option of not doing garbage collection, and now my mind is really racing. I can't wait to see where this stream goes. This is great. My mind
Yeah,
is,
I love
I'm
it.
racing.
Yeah. Okay, so we talked about memory consumption and container size. What if we need to reduce the startup time, right? So we saw that Pet Clinic starts in about 4 seconds,
Mhm.
4 plus or some milliseconds. What if we needed to start faster, right? So we
Yeah,
have, yeah,
I'm
real,
scaling. I gotta catch up
yep,
to the traffic, and a
exactly. Mhm.
commercial break sometimes only 30 seconds. And if it's taking me 5 seconds to scale up these applications, I might run out of time. I might not meet the demands of my users that are only visiting my website during the commercial break, or like at the start of the trading day. Right?
Yep.
We don't know how many trades are going to happen at the start of the trading day. Who knows what was on the news last night? Those milliseconds matter. Latency is the new downtime. So the startup matters, right? And
Yes.
this has been a big kind of I don't know, a
Big
distraction,
topic
right?
in
Where
the Java
other
world. Yeah.
languages, they're like, oh, Java can't do it. Java can't start up fast enough. And we saw this last time. We know that there's other things that we can do to improve the startup time.
Yeah.
So yeah, this matters
Yeah.
for a lot of reasons.
Yeah. So yeah, Dashawn and I did a live stream on Java Startup. So if you haven't seen it, please do. That's packed with goodies, right? So there are 4 options. There's Project Layton, there's Crack, Coordinate Restore Checkpoint, there's Native Image, and there is CDS, right? They all give different results, right? And well, the implementation difficulty is also different, right? So CDS is the simplest one, right? So again, you don't have to change anything in your application. Any application will work with that, definitely, right? 100%. So if you don't want to do anything, but you need to reduce the startup at least a little bit, then CDS is your way to go. And the Buildpacks provide us with 2 opportunities of reducing startup. So we can use CDS with Buildpacks, and we can use native image with Buildpacks, right? Again, just 1 line of code. That's it, nothing else.
Rajiv's
And
question here. He's saying, hey, the problem, Buildpacks memory tracking, like how are we supposed to get that information? You're going to get it the same way. If you're using Prometheus with Spring Boot, we can still expose those metrics. And I think we're going to jump into that right now. We can still use Buildpacks to expose these metrics, whether you're attaching an agent or there's other options by putting these metrics on an actuator. You can pull or you can use the push. So there's different approaches to that as well. But yeah, you're getting to the point where like, hey, this is fun stuff. I think that we can, Rajiv, you and I think we should have a conversation. I'd like to hear more about your use cases and why you're using Docker files. And let's see if there's things that you're doing in your Docker files that we can't do with Buildpacks. But thank you so much for these questions. This is great.
Yeah, great questions. Thank you, guys. I mean, that's great. That's a very lively conversation.
Yeah.
That we're having here.
Spring Boot allows us to put actuator endpoints. We can put a Prometheus formatted metrics on our metrics endpoint, and we can scrape like Prometheus does. So we can do all of those things at the app layer. I think he's saying that he's doing at the container level too. So yeah, that's something to look at.
Yeah. All right. So right now we are going to enable CDS with Buildpacks. And again, the beauty is that you don't have to manually create the archive, or specify the command for creating the archive, and then specify the command for using the archive. Buildpacks are going to do that all for you. Right?
That's amazing. Do the training run, capture the metadata, and then reuse that metadata going forward.
Yep, exactly.
Class data sharing.
Right. Yeah. So we're going to use CDS with AOT, right? So to reduce startup even more. Process AOT, that's the goal that we need to add, AOT, right?
I'm putting a link to our last episode. I'm putting a link to that in the chat. So if you want to see all the other stuff that we did with the JVM before the Buildpacks, you can go and watch that episode.
All right, so I just commented out the jlink here, but we'll return to that. Right now we are using purely CDS and AOT. So for that, we need two other options. So that is BP JVM CDS enabled. And we're setting that to true, of course, else why would we use it? Okay, so CDS is a JVM feature, right? And Spring Boot natively supports it.
As of Spring Boot 3.3. Before that, we didn't. But this class data sharing archive is not just a Spring Boot thing. It's something that's been around for a long time. There's other frameworks, there's other apps that were able to take advantage of class data sharing. And now with Spring Boot 3.3, your Spring Boot apps can take advantage of class data sharing as well. And the Buildpack here, we enabled it. You don't have to do anything else. You enable it, and what the Buildpack is doing, it's going to, actually, we'll see it in a second. It's going to do a training run. It's going to load the application and create that class data sharing archive. So it's not, it's not doing a full app, a full end-to-end test. It's doing the startup, and that's what we're getting the benefits, is we're getting the benefits on startup.
Yep, exactly. Right. And the second option that we need is BP Spring AOT enabled. So that is already a Spring feature.
Okay.
Right. And it's going to perform some ahead of time optimizations.
And we don't have to use these both together. We use one or the other.
Exactly.
But the cool thing is we can use them together. This is fantastic.
Yeah, and Spring AOT, well, you don't have to, again, ahead of time optimizations with Spring, these optimizations are not as strict with native as with native image, but they are more fit to a wider variety of applications, right? So you don't have to use native image if you don't want to, right? You can still get the benefits of ahead of time optimizations with your favorite Spring. But right.
It is my favorite, in case anyone was wondering. Spring Boot is my favorite. You should be using it. Tell your kids they should be using it.
Okay, so that's it. We enabled CDS and we enabled AOT and we added the Go process AOT. That's it. Oh, and let's change the name of our image. So this time it's pet cleaning CDS. Or CDS. Okay. Okay. Like a run. Yeah. Right. So, yeah, as Dashan said, there's going to be the training run. Here it is of our application. Then, so the archive, CDS archive, will be created, and it will be used during our production run. Okay. Yep. As well as some pipeline processing. So as you can see, there are
So
logs from CDS.
this is the training run that we're looking at right now. So it's standing things up. We're building that class data sharing archive so we can get a faster startup when we deploy it. Okay, this is great.
Yeah. So with CDS, there is the archive of classes, pre-initialized classes. Not all classes get into the archive, but most of them, right?
Okay.
And so using pre-initialized classes is faster than loading them. So startup is going to be faster. That's the idea of CDS.
Can you do me a favor?
Yep.
Can you run Docker history against this image?
Yes, of course.
And I just want to see if I can see a layer for the CDS archive.
Yep, exactly. Right. So let's just check it. Okay, Docker images. So here it is. So yeah.
All right. This is the biggest one, but this makes sense. What I'm hearing, right? What I see here is I built another layer. I'm adding information to this build pack because I want it to start up faster. So I built another layer with this class data sharing archive to give me a faster startup. Okay, I'm comfortable with this. Let me see.
Yeah, so let's see Docker history. That's Docker history. Let's check it. So
it looks different, right? Before if we do a Docker history against the Pet Clinic standard, remember we saw like 5 of the application layers.
Yeah.
Because it was doing the extracted jar. Yeah. And it was building, I think it had a layer for like my dependencies for my app code because it was more worried about the build caching and being able to reuse those layers.
Yeah, so we can compare it, right? So here it is,
the
standard and CDS. Yeah,
yep. So I have multiple application slices on the standard. I have one application layer. Okay, but a lot of it's similar. And I was looking, there wasn't a layer that was labeled as class data sharing archive. That's just what I wanted to see. And I think that would be valuable to have that layer labeled. So guess what? That's a great opportunity for a pull request.
Yes. Yeah, we should know that.
I want to write that down actually.
Yeah.
So great. Fantastic. Thank you for doing that. I didn't want to throw you after game, but.
Okay, so let's run our image with CDS. Okay, can run Pet Clinic CDS and see how fast it starts. Okay, haven't forgotten anything. Oh, memory. Right. Well, you don't actually have to limit the memory.
I like
good practice.
I like that for the consistency, right? If I'm again for me in my job, what we're trying to show is like I have options here. So all the work that I'm doing inside of the build pack, even when I deploy it, the containers options, how much room it's going to reserve, etc. These are important things. And if your application has a memory footprint that goes like this, that number has to be right? Because if you bump into that number, you're going to run into problems. It's going to exit and hopefully your platform will restart it. But you've got to have some insight into what your application is doing. We have a simple project here and our garbage collection is working for the types of things that we're doing. So that 1 gig limit is nice. We're not giving it too much of a reservation. And if we're consistent across these applications with the same reservation limit, then we're going to get consistent results. We'll get results that matter instead of, oh, one of these runs got a bigger reservation than the other. So this is great.
Okay, so let's run it. And yeah, as you can see, it started in 2.
Okay, this is a huge improvement.
Yeah, I'm amazed myself. Usually
this is a trade-off. Our trade-off was now we have a bigger container size, but a much faster startup time. This is great. Now let's go look at our committed memory.
Yeah. Okay. That's
all right. Similar, right?
Similar.
Yeah, 231. So yeah, right in the same ballpark, but the startup time is hugely improved. Fantastic.
Yeah. Yeah. So yeah, there's this trade-off, right? So bigger container, but faster startup. But Dashan, what do you think? Can we kill 2 birds with 1 stone?
I've kind of been waiting for this since the beginning. I want to know if I can get a smaller container size and the faster startup.
Okay, let's see.
But I don't want to go to native image yet.
No, we are still on our JVM, hotspot JVM.
Fantastic.
Let's see what we can do. So let's see, namely, can we use CDS and AOT and jlink, right? So,
Can we?
okay, can we? Let's check it. So I commented out this line here, and I'm going to uncomment it. Oops. Yeah. And in real time, we are going to see whether we can have
What's going
both.
to happen?
Yeah, what's going to happen? Whether we can have our cake
I
and
feel like this is going to work. I'm hopeful.
okay.
I'm hopeful.
Let's see.
Oh,
Yeah. Oh, I forgot to give another name to our image. Okay. So we are going to call it Pet Clinic CDS jlink. Jlink. Okay. So everything's fine. Everything's fine. Okay.
so I'm going to optimize my Java modules. Then I'm going to do a training run with just that set.
Theoretically, it should be possible, right? Because that's the same.
It makes sense to me. I want this to work really bad.
Yeah. Well, let's see right now.
I want it to work.
Okay. Well, that's actually the only point of consideration with CDS, that you should use the same JVM that you created the archive with to run your application, right? But here we're using the same JVM. That's the same version, Iberica, right? So everything should be fine. Okay. So we are going to see. Okay. So here there's our training run.
So we did our training run?
So it is. So far so good, at least.
Fantastic.
Yeah, so no errors as far as I can see. Right. Okay, build success. Okay.
All right, so first let's look at this. How big is this image?
Yes. Okay, so let's check it. Pet Clinic. Okay, so let's look for it. Yeah, Pet Clinic jlink. It's 432.
But it's 120 less. Like that's
100 megabyte less. That's okay.
Yeah.
That's better, right?
Yep.
So, well, let's try to run it, whether it's going to be successful or not. Right.
So adding CDS,
yeah,
I have a bigger image size. But if I do jlink, I can improve. I can reduce the amount of the image size getting bigger. So this is I almost feel like if I'm using CDS, I should absolutely look at using jlink.
Oh, yeah.
Now look at this.
It's 3.6. Well, actually,
we changed two knobs, right?
Yeah.
We said, hey, my image size is smaller, but I increased my startup time a little bit, but still, it's faster startup time than what I had with the standard. It's faster startup time than what I had with the others. So we have knobs to adjust.
Yeah.
So
so it's the startup time is never carved in stone.
Yeah.
So it varies. So if we run it again, let's just try for sanity's sake
to see what that delta is, right? I should do your math, do your statistics, so we get a good sampling.
3.6 again.
But still, it's faster than what I was doing before. All of the previous ones, because I added that class data sharing archive, so I expect it to be faster.
Well,
this
actually,
one has a smaller.
Actually, usually when I run CDS and AOT with Pet Clinic, the startup is about 3 point something. Okay. So for me, 2.2, that was a huge Überraschung in German. So,
we got lucky. Okay, go run the CDS one again.
Yeah.
Because maybe that was just an anomaly. You know, we'd not been talking for a little bit or something. Let's run the CDS one again, and let's take a look.
What? 2.2?
Okay, wow. So that's good.
That's great.
But we didn't look at the committed memory on the jlink one.
Oh yeah.
I'm not expecting any big changes.
Okay, let's see. So yeah, here it is.
Okay, so a little smaller than the CDS alone. Okay, so again, we have knobs, and the things that we're looking at right now are really the container image size, the startup, and the committed memory. Like how much memory is it using as when it's running? This is good.
Yeah. So yeah, again, you can run your project with different settings, right, and see what's best for you. Whether reducing startup is super critical or whether disk size is more important, right?
I
And
just
here you
unplugged
can
my
leverage.
laptop. Sorry.
Yeah. So here you can leverage both, well, slightly, but again, that's everything's just as you see fit, right?
Fantastic.
Of course, we can get even better startup with native image.
Of
Right?
course we do native images.
Yeah, we still haven't touched upon native images, and well, why not do that? That's the last thing I wanted to show you today. Right. So here we have GraalVM build tools, native Maven plugin. This is if you want to build a native image and run it on your local machine.
Okay.
If we want to build a container image, we are going to use the same Spring Boot Maven plugin, and the command is going to be the same, Spring Boot build image, with only addition of a pnative. Yeah, so we are testing our plugin, but we want a native image this time, right?
Okay.
So I am deleting all these options because we don't need them anymore.
Okay.
Actually, if you want a default native image, you can simply run the build and get the native image without any additional configuration.
Okay.
Right? Okay. But I think I deleted something, or maybe not. Maybe not.
Right now we're using the Paquito build pack.
Yeah.
Honestly, I want to see a native image with the Paquito build pack, and then I would like to see a native image with Alpaquita muscle. Can we do that?
Let's try. Okay, so we are going to use, this time is going to be path cleaning native image.
Okay.
And what I wanted to show you is that you can actually tune the native image. So as I already mentioned, the performance of native image is quite okay, right? It's not the same as with the JIT compiler because there's a limited number of garbage collectors.
And it depends on what you're doing, right? So native image, we're going to see some amazing results here, but again, at scale, Rajiv, you're going to want to do some validation. You're going to want to make sure, because the JVM is still absolutely amazing, and these native images are going to give you a smaller footprint, probably a smaller container, smaller memory footprint, but not all workloads are going to perform better on a native image. So do your homework.
But actually, Cat Buildpacks use Liberica Native Image Kit under the hood. And Liberica Native Image Kit includes additional collector, which is a parallel GC, right? So in Community Edition, there is serial GC and epsilon GC. And with Liberica Native Image Kit, you get a parallel GC. So you can enable that, and the performance is going to be slightly better.
Fantastic.
Which we are going to enable right now. Again, unfortunately, right now we can't test the performance of garbage collection, but as we already promised, we are going to do a session on garbage collection, so stay tuned. Right now, I'm just going to show you how to enable it, right?
Okay.
Okay, so we need another option, that is BP native image. So we are already working with native image and with its special options. So BP native image build arguments. And we are going to enable parallel GC, so that's GC parallel. You can also set a number of threads. So by default, the parallel GC in Liberica Native Image Kit uses 1 thread per core.
Okay.
The maximum size is 8 threads per core, so you can again tune it. You can set the number of threads, right? Well, right now we are just going to go with the standard settings. So GC parallel, BP native image. image build arguments. I hope I'm not making any typos. Documents, yeah.
There you go. Yeah.
Got that. Yeah. Okay. Right. Configuration. And we wanted to use Alpaquita, right? Okay. Builder. Okay. Soft. Builder. Buildpacks. Builder muscle. So Buildpacks, builder muscle, GC barrel. Okay, that's it. Pet clinic native. Alpaquita, just for the sake of sake. Okay, that's it. Right? Next.
Okay.
So the command is the same, only with additional p
Native.
native. Yep. Right. Okay. So yeah, so building a native image is well, that's a longer process.
Yep. So this is taking our bytecode, and we're using the native image kit to go and analyze that bytecode, and we're converting all of the bytecode down to native image code. So on your computer, whatever operating system, whatever architecture you're running, this native image is only going to work on that operating system and that architecture. It will not run on other things. So there's another trade-off.
Yeah, exactly.
But
yeah.
It has everything it needs from the JVM,
Mm-hmm.
from the app. And in this case, we're using Tomcat, the Spring Boot, applications using Tomcat. So that is actually going to be included as well. All this in a binary, which is fantastic.
Yeah. Right. So as you can see, we are using parallel GC, right? So we enabled it. And so when you are building a native image, it is a very resource demanding process, right? So right now it needed 11 gigabytes of memory.
Yep.
That's okay. That's okay. That's only for the build time.
Yep.
Right? So
I build it once. I run it thousands of times.
Yeah, exactly. So that's totally okay. Right. And yeah, again, it may take several minutes, but only for the build time. After that, you're going to enjoy the fast start time.
I'm going to tell a little story. I recently got a new computer, and I do a lot of native image builds. I demonstrate this with customers all the time. I'm going through a lot of the stuff that we showed last time and some others. And I was so happy when I did my first native image build on this new laptop, because I've done it so many times on my other computers. I kind of know which computer is going to take how long. And my fastest other computer, my typical demo build of a Spring Boot 3.3 application was taking about 1 minute, plus or minus a couple seconds, but never under a minute. It was like a minute 2 to a minute 10 on my fastest computer. And on this one, the whole process took 30-ish seconds, 40 seconds. So that my new path forward with this laptop, I gotta hold 20 seconds, 30 seconds of buffer that I get to just chit chat. So this is amazing. I got a whole 30 seconds. Every time I do this demo, I get 30 seconds extra in my life, and it's fantastic.
That's cool. That's really amazing. As far as I know, the latest Growl VM version has an option, build time option, that enables you to accelerate the build process. Right, so it's going to be faster.
They have so this is good. This is a thing that, for the applications that I'm typically doing, a pet clinic, a hello world, a simple application. For those that I don't remember what the tag is, like fast build or something like that. The improvement in the build time wasn't really worth the results because it did build a little bit faster, but it wasn't significantly faster, and it's doing less optimizations. So the delta between my native image and my JVM, it was smaller because, again, now we have CDS and AOT. So the gap between what we do on a JVM and what we do as a native image, that gap keeps on getting smaller. And continuing to go forward with Java, it's going to continue to get smaller, right? Because we have all of these new features. Valhalla and Layden are making it so we're going to get even more optimizations out of the JVM.
Yeah.
So yeah, we have options.
Yeah.
This is great though. There is a fast boot option that if you're doing the native images, you can optimize for a faster feedback loop. But yeah, just in my cases, I didn't see the benefit of doing the fast boot, so I don't use it very often.
Yeah. So again, yeah, you're right. There are trade-offs, right? So faster build time, less optimizations. That's not what we're looking for, right?
Yeah.
So we can wait for extra minutes, even. Why not? Right?
Yeah, it's in there. It's in your builder, right? It's in Jenkins. It's not. Hopefully, it's not blocking anybody else from going to production. And if it is, it's for an extra 45 seconds or whatever.
Yep.
But do that. That's. I highly recommend building native images in your pipeline, because if you're wanting to run these images, right, all the images that we just built here, if I'm given the option to download one and to run it on my laptop, I'm going to choose a native image, and we're going to see why.
Yeah, right. So our image is ready. So it took 3 minutes. Well, that's okay. It's not 10 minutes. Let's check it. Native Alpaquita. Yeah, it takes 210 megabytes.
This is interesting.
Mm-hmm.
That it is not as small as the Alpaquita one.
That's actually okay, because the native image contains some precompiled code, which may take some space.
Yep.
First of all, right?
I'm just surprised.
Yeah.
Great.
So that's again, that's smaller. Anyway, that's smaller than the standard pet cleaning.
Yep.
Right, so you can see the difference here.
Mm-hmm.
And well, yeah, it's a bit bigger than just the JRE and Alpaquita, but yeah, again, because of some native image characteristics. So that's actually quite okay. Sometimes if it's a small application, yeah.
When we selected the Bellsoft builder muscle, it's using Alpaquita?
Yeah.
I don't think we used Alpaquita muscle.
You think? No, there was a muscle builder. Oh, wait a sec. Found.xml, because we would have to specify the glibc explicitly.
Okay.
Right. So yeah, it is Buildpacks builder muscle.
So by default, that builder is using Alpaquita's. Okay.
So yeah.
All right.
Mm-hmm. Okay.
Fantastic.
Yeah. But again, as I was saying, in the case of smaller, simpler apps, the size of the native image can be, really like several megabytes. That's it. So they can be really small.
Okay.
It all depends.
And with native images, one of those additional features that we can add on, just as a Buildpack config, is we can compress it. And we have a couple of options, right? We have what are they? They're different. It's not the same zip options, but we can compress that native image as well. Do we want to do that?
Interesting.
Hold on 1 sec. Let me find it. I'll try to do it over here. Java Buildpack native image compression. Oh, I'm not connected to the internet. Let me try that over here. Java Buildpack native image compression. And the option is BP binary compression method. I'll put that into the thing, and we can use UPX or GZEXE. So I'm going to put that here into chat. This is our config. This is the flag, and the value for that is it's non-UPX or GZEXE. And I have not had any success
in using it
with UPX compression. I do, but when I'm talking about that, I'm talking about the builder that I created for ARM64 support. So we have another step. So here's what I would like to do. I would like to do this same thing. I want to add an environment variable called BP binary compression method and add UPX. And let's see what we get.
Okay.
I'm taking you completely off script, but this
Mhm.
is what I do. My mind is racing. This is exciting stuff.
That's great.
So let's edit this POM file.
Okay.
And,
Let's
oh wait,
just
we didn't even run this one yet.
yeah, let's run. Yeah,
Yeah.
let's run it.
We're
And
getting ahead
then
of
we'll
ourselves.
move. So as you can see, our
Oh my goodness.
Cat Link application started in less than a second, 15 milliseconds. That's amazing. That's just
From
excellent.
for almost 5 seconds.
Mm-hmm. Yeah. So I love native image. The startup is almost instant, right? I
That's
didn't even have
fantastic.
time to finish my sentence, and it already started.
That's fantastic.
Yeah. Okay, so you're saying that there is this option, right? Just a sec. You show it's in the chat, right?
Here, I'll put it up on the thing. It's BP binary compression method.
Uh-huh.
I'll put it over here. In the chat. BP binary compression method. Whoops. Method.
Okay, and we're specifying
None UPX or GZEXE. Oops.
All right. Okay. So sharing the screen.
So I would like to try UPX first because I've seen it work on my other Buildpacks.
See? Okay.
Let's take it for a spin.
Testing. Okay, share. So can you see my?
There we go.
Here we go. It's okay, right?
Yep.
Yeah. Okay.
Actually, that looks great.
Yeah. Okay. Great. Okay, let's see what we can do. .pom XML. Let's return to our configuration. Oops. POM XML. Okay. Don't scare me like that. Okay. Right. See barrel. And that's BP. All right. Binary compression method. Okay.
UPX.
UPX. Like that, right?
Yep.
So okay. Okay. And we'll call it Pet Clinic Native Alpaquita UPX.
Perfect.
UPX. Okay. Oh, I'm excited. I haven't tried that before.
So in my head, and again, I haven't read the documentation in a while, but in my head, it's compressing the native image binary. So the only thing that we're going to see is we're going to see a larger startup time because it's going to uncompress that binary. But we're going to have a smaller image. So again, we've got another knob for what we're trying to optimize. This UPX compression is going to optimize. It's going to make the disk image smaller, is what I'm expecting. Let's see.
You won't believe that, but the native image is ready. I'm amazed. Maybe you just pulled something from the cache. All right. That's interesting.
That is very interesting.
Yeah. So, okay, let's see. JRE, native Alpaquita. Maybe I didn't. Did I specify? Yeah, native. Oh.
Did it do? It didn't do the Graalvm.
Yeah. Yeah, that's weird.
Why?
I don't know.
Um.
Okay, let's see what it used. Right. So, Graalvm reachability metadata repository. So it's actually used Graalvm.
But it didn't go through the steps.
Yeah.
Oh, I wonder if it had the native image already. Did it pull it from a cache layer? I don't know.
Well, that's possible.
Look at. Well, yeah. Let's see. Let's look at the image size.
Yeah.
We'll find out.
Okay, so we're UPX. Oh yeah, it is 108 2 megabytes.
All right, let's start it up.
Okay.
And let's see if it starts up in our milliseconds, then we did something.
Mm-hmm. Okay,
'Cause
native
the
Alpaquita.
reason why I expected, and what I shouldn't have done, the reason I expected us to go through the thing is because my build pack wasn't smart, but Buildpacks also built in that caching so that it can reuse the layers when it detects it. There was no change to the code, so let me go ahead and use this binary that I have,
Okay.
and
Yeah.
with the compression, maybe just optimize the previously built binary. So we'll see.
Okay.
This
All
is my
right.
guess. I'm
See,
guessing,
yeah. So I'm
but I'm
super
excited to see like what's going to
That's
happen
something
here.
new. All right. Okay. Fingers crossed.
I saw the native image, so I don't think it did because I saw the
Uh-huh.
memory image stuff. So yeah, so
4.6. Okay, that might be
so I don't think it did the native image stuff. So I think what we have to do
yeah.
here is we have to explicitly add BP native image.
Yeah. Okay, let's try it once again.
BP
Maybe
native
that's
image.
wrong.
Nope. I think in our config we have to explicitly say BP native image. Set that
Okay.
to true.
Okay.
As I'm looking, because I'm looking at the native image build pack.
Mhm.
But the other thing is, I'm using the muscle build pack, so maybe this isn't a feature in the Alpaquita build pack, but we'll find out. So
yeah,
we'll find out. Let's add the BP native
image to true,
image.
right?
Yep, to true. While you do that, I'm going to go look at the Bellsoft builder.
B native image. Okay, that's it, right? Like that.
BP native. Yes.
Yeah. Okay.
So I'm looking at that BP native image build argument. No, BP binary compression method. That's from the Paquito native image. So I'm pulling from there, and I'm going to go look at the Bellsoft to see if it's. Let's run this. Let's see.
Yeah.
And,
yeah. Okay.
And if not, then we have. Oh, here we go. I'm looking at.
Okay. Okay, I'm curious myself because if it's not supported with Alpaquita, maybe I could just.
I mean,
talk to my team.
Pull requests, right? Pull requests are welcome.
Yeah.
Look at Alex is here. Oh, my shirt is rubbing on my mic. He says, I think your mic is rubbing on your shirt, so your amazing tones are coming through a little scratchier than normal. Thanks for that heads up, Alex, and I'm grateful that you're here. Thank you. I'll remember that. I'm traveling. So again, it doesn't look like.
Yeah, it doesn't look like it actually.
Okay.
Yeah.
That's okay. It was worth. The experiment.
Yeah.
But I want to see if the build pack that we're using. I want to see if there is a similar option. Where do I find the docs for the Alpaquita build pack?
On GitHub, I guess.
I had it last time. I found it easily last time.
Okay, just a sec. I'll try to find it myself. Native image. Okay, by the way, maybe there. No
matter what happens, this has been awesome.
Yeah, Buildpacks Alpaquita build. That's Docker Hub. Okay. All right. Okay, well, that's the point for discussion with the team.
Yeah. Here we go. Build pack. How to install. I'm finding all of the blogs, but I can't find like the
documentation, right? Yeah.
but that's okay.
That's okay. Yeah.
We'll do that on the next one. Again, I like to go off script, and that's fine. We'll find it. Kat,
Yeah.
thank you so much for hanging out with me this morning, evening for you. This was good. This was fun. Thank you for letting me take you off script. There's a lot of really cool things that are coming and continue to come. You did a great job of demonstrating and explaining. So thank you. And I really hope that we can do this again.
Yeah. Thank you, Dashawn.
Any-
That was lovely to be here.
Anything else? Last words? Things that our viewers should take a look at? Final notes.
Yeah.
What do you got?
Yeah. So right. So if you want to experiment with Buildpacks, I wrote an article, a guide.
Oh,
So you can just use some copy and paste examples that I showed today from this article. So we are going to add it to the description box of the video, right?
Yep.
Yeah, so it's going to be there. And yeah, so visit our Balsoft's blog. There you can find lots of.
I put the link in the chat for all of our viewers.
Yeah.
Fantastic.
Yeah. So yeah.
We'll start there, and then until next time.
Until next time, definitely. For more performance tips.
Yes, I'm going to end the stream, but stick around. I'll talk to you after.
Yeah.
All right. Thanks, everybody.
Bye-bye, guys.